Alright, now I'm just going to practice solving some examples of the definite integral using the fundamental theorem calculator. Again, the notation's important, so when you solve this, and I ask you to solve this by hand using fundamental theorem calculus, this is the notation I want to see. This is the work I want to see. Alright, correct notation and work. First thing you always write down is the general antiderivative. And so in this case, it's going to be 4x squared divided by 2 minus 2x minus 2. Minus x cubed divided by 3. Again, not done yet. I still have to take care of the 0 and the 6. Which again, if you want to rewrite that, simplify, that's 2x squared minus 1/3 x cubed from 0 to 6. And then you find the numbers by plugging in the 6 and the 0. And again, I want to see the numbers and give them exact. So if they're fractions, hit your fraction key. Alright, so when you plug 6 in, actually 6 comes out nice, it comes out negative 12, and 0 comes out nice, it comes 0. So it's negative 12 minus 0, and so the answer is negative 12. But I want to see this, right? This is what I want to see because this is the fundamental theorem of calculus. Which that means there's more negative area, right? Because it's a negative number that comes out. Next example, again, show the general antiderivative. So the general antiderivative of negative 4e is negative 4e to the 0.2x divided by the 0.2. Don't forget to divide by that 0.2 plus 5x from 0 to 3. Again, you could leave it like that, but I tend to clean it up. So negative 4 divided by 0.2 is negative 20e to the 0.2x plus 5x from 0 to 3. And then you plug in your 3 and your 0, and you give those numbers. All right, so when you plug in 3, you get negative 20e to the 0.6 plus 15, right? I'm plugging 3 in. And when I plug in 0, I get e to the 0, which is 1, so that's negative 20 plus 0. And so the exact answer in this case would be negative 20e to the 0.6 plus 35. And then the approximate answer would be negative 1.442. Which means, again, there's more negative area in this example again. But that's the work we want to see. Alright, same thing again using, and I'm going to go ahead, I'm just going to finish off solving these since again, there's just 2 more, actually there might be more than 2 more examples. Alright, so I'm going to finish solving this one, then maybe I'll stop there and then I'll pick up the last few in the next video. Alright, so 1 to 8, x, so first thing before I get started, I'm going to rewrite my cube root of x as x to the 1/3 minus 2. Then find my general antiderivative, which is x, add 1, right? We're adding 1, make sure you're careful. So I get 1/3 plus 1, it comes out 4/3. Right? And then remember, instead of dividing by 4/3, because that's an ugly, complicated, that's an improper fraction, we multiply by the reciprocal. So multiply by 3/4 minus 2x from 1 to 8. And then you plug in your 8 and your 1 and take the difference of the 2. And again, these are going to come out fractions, so hit your fraction key. Actually, 8 comes out nice. It comes out negative 4, but 1 does not. It comes out negative 5/4. So negative 4 minus a negative 5/4, really negative 4 plus 5/4. So that simplifies down to negative 11 over 4. Which again, so most of these so far that I've set up are more negative. Alright, I'm going to stop there just to split up the video into 2 videos of solving. So I'm going to finish up the rest of them in the last video. So we'll stop there.